more info on this new thing called as multi-agent systems. And in this talk, we'll be actually having it actually two segments. The first half of the talk, it'll be more about like why do we actually need a multi-agent system? So when I call something a system, what does it mean? And the second half would be like we'll look at some features of crewAI and we'll see some demo and also like what and other similar frameworks which you can actually try out and how the multi-agent principles are can be implemented leveraging crewAI. So the next slide, we can see the first four will be the part of the first half. Like we'll see the journey of how we came to multi-agent systems. And the next half, we'll see like what and all features crewAI gives. Like if you would like to build your own use case, what you would need to kind of get started. So to start off, right, we have something called prompt engineering. I have a feeling that everyone will be kind of familiar with ChatGPT. With the advent of ChatGPT, prompt engineering gained like a lot of traction. Like you have to ask the right kind of questions to kind of get the right kind of answers. Like you have ChatGPT, you have Gemini. You give a question like say, "Hey, I want you to give me some information on maybe let's say Geek Night." If it knows if it's been trained on that particular data, ChatGPT will be able to give you that kind of output. And initially, people just started simply asking questions, and the large language model will try to give you the answer. Then there was this rising trend wherein people found out the quality of your output is like directly proportional to the quality of your input. So we started going towards like different prompt engineering techniques. Like this is one example, Piado, wherein like if you want to ask ChatGPT a question, let's say you want to give it, want the LLM to give like, you a code, like let's say for a tic-tac-toe using React. Then you will say in the persona, hey, I'm actually an experienced React developer who has like very well versed with responsive web design and JavaScript I'm very good at. And the information you tell, like this is something that I'm actually developing for like a mini project in my college. This is something that my organization wants me to build. And in the action, you tell ChatGPT what you wanted to do. Like give me the React code in kind of like in this part, and for like let's say I want to maybe make in the tic-tac-toe, right? Like the user input, whatever you give, I want to kind of handle that. Give me the code which kind of does that. And rules will be like ensure that like you don't use any libraries which have some issues. The code it should have some good clean code patterns, and the output in whichever format you want. Like if you want it in JavaScript, yes. If you want the JavaScript to be in like just a text, you can ask, or if you want that to be in a different kind of format, in a JSON file where you have a key as code and the value to be the code, that also you can ask. And all of this starts with prompt engineering. But there was a problem. There are many problems with prompt engineering. So the large language models are limited to what they are trained on. So when GPT 3.5 kind of came to be, people were actually like trying to ask like, hey, can you give me the code to do this? But what ChatGPT was doing is 3.5 was only trained till like 2022 or something. So any library or new Python ways of doing things came after that. The LLM was not able to give it because it had no context, no information about what that was. So it was limited by static knowledge. Second thing is hallucinations. In the same example, one time when I actually asked ChatGPT to give me some Python code, it told me about a library which will kind of exactly do what I wanted to do. But when I tried to find out more information on this library, I realized that there is no such library. Just ChatGPT kind of came up with something, and I was like, "Okay, I thought it solved my problem, but it just made me realize like I'm not doing things right." And the final one is lack of context. Yes, prompt engineering solves a problem, but at some point of time, you need to set that limit wherein how much context am I going to give? Because LLMs can only take in so much. So you can't essentially give everything to large language model in one shot so that it will get overloaded with that much of information and your response quality starts decreasing. So when this prompt engineering was facing these challenges, they came to be the next thing, which is called as retrieval augmented generation. Now, retrieval augmented generation is something that many organizations have started kind of adopting and are right now working towards moving it to production. This is also not like a silver bullet, but this is like at least something better. So in RAG systems, as we call it, what they do is, if I ask a question, instead of just relying on the large language model's knowledge base, you kind of give it your own documents or any other code files that you have as a specific knowledge base. And from this knowledge base, the ChatGPT or any other large language model will use that document's content as a way to give you the response. So if you see this architecture, you ask a question, you have like a smart retriever. So the very first time you ask a question, the smart retriever, what it is going to try to do is find out what and all relevant information the documents kind of have for your question. And once these information are kind of fetched, the prompt that you kind of give the LLM, this additional documents information is also added on top of it. And finally, the LLM gives it. So here also, the only thing you're doing is you, instead of you giving the LLM the prompt, you leverage an external additional system, additional component, which will do that job for you, wherein I will give you that PDF, PPTs, all the documents. You find out what is the best one based on some similarity search, and then using that, you kind of give me the response. So yeah, this is the same thing. RAG is broken down into three things. Retrieval is the part where you get the information. Augmentation is the information that is fetched and the prompt that you're asking. Both of them are combined. And finally, the generation part is where you ask this question to the large language model and it will kind of give you the output. So RAG overcomes some challenges of prompt engineering, wherein since you give it documents, it will use that knowledge instead of just a large language model's existing knowledge, and it will have some up-to-date information. And since you have something for it to kind of relate it to, it will be able to fact check, hey, I'm not able to find this information in the document. So hallucinations are not completely eliminated, but are reduced to some extent. But RAG also starts to have some kind of challenges. Like in a company, right? Like, or any other use case you take, they might not have like a limited set of documents. Like it's going to be maybe in thousands, hundreds. So in that kind of scenario, a single RAG system is not your ideal solution where all your information might not be available in the set of documents you have. So that is where single retrieval source kind of fails. And it is also a static process. Like in RAG, what it all does is it goes to the document, gets the information, but if those documents does not have that information, it might not know what to do. And it is kind of stuck to that kind of routine where it has to do this retrieval and augmented and generation part. So this is where the next thing came to be, LLM-based agents. So LLM-based agents was like, we know that if I ask the LLMs that these kind of questions, I can get it. What if the LLM itself can kind of reason it with itself? Like, what if, like, if you take a human scenario, if someone asks me a question, first I'll maybe give an answer. Then I'll maybe think to myself, hey, what if like this is not the right thing? Then I kind of maybe tweak the answer a little bit. This kind of reasoning that I have within myself, like I keep on questioning it. Is this right? Or should I maybe give some more information? Or do I need to do something else to validate what answer I'm giving it is actually right? And that's what agent is all about. It is trying to mimic that human behavior, wherein instead of just directly giving the answer, the LLM kind of questions itself, does some kind of reasoning, and it has some additional support to kind of validate is the reasoning right or not. So the architecture, if we see, you have like two options to build agents by means of tools like LangChain. So if you ask an LLM, a regular LLM, this question, what is the current population of Italy? It will just say you what population it knew at the time it was trained on. RAG can also help to some extent. And in the similar context, how agent will help you is, you can give the agent some kind of access to tools like Wikipedia API or some database. So the agent itself will query that Wikipedia or any API and get you that relevant information and give you with the final answer, hey, this is the current population of Italy. So this kind of opens up new ways of doing things because in a regular context of doing things, we have a lot of things based on APIs and other kind of interfaces. So by means of giving that agent this access, even our regular websites that we build or any other APIs that are available publicly, the agent itself will go and fetch it and give us that information. So this is another example of how an agent does things. So if I ask a question like, what is the square root of the average age? So first the LLM will kind of think, hey, for answering this question, I need to have a thought, which is to calculate the average age. And we give it a tool wherein it can actually start executing the Python code by itself. Instead of we taking the code and executing, the agent itself will be able to get like a Python environment where it will try to execute the code. And the action input it gets is like in a data frame, it will have age and it will try to calculate the mean. And we see it gets like 29.699. So we have the average age. So the next part of this equation is like I need to kind of find out the square root. So once again, it has this thought like, hey, I have the age. So let me try to find out the square root. And it finds out like math.square root function is available, wherein I can try to get the square root value. Then the agent finds out math is not defined. Like I don't have that model at all. So in your regular prompt engineering, the system breaks here. Like the system stops. It does not know what to do next. But an agent, it will try to find out, okay, once again, you'll ask the LLM and the LLM will say, like, you need to import the math library. So the next time the code is run, it will first run the import math part, and then it will start running like math.square root and get you the final answer. So the LLM kind of starts doing the plan. Like if I given a complex question, how do I break it down so that I can solve it? A tool where what are the external things that I can start using to kind of answer this, and how do I make my answer much more better? So all this example, we can kind of attribute to this next diagram, the anatomy of an agent. We have 4 components here. To the right side, you have planning. Given a question, it will use some kind of techniques to kind of break it down. Like uh, the same example, like square root of an average age, it knows like first I need to calculate age, average, and then I need to calculate the square root. And the next thing is memory. So in your prompt engineering, it's kind of sometimes stateless, wherein like it might not remember what you were asking like 10 days earlier or what you asked in the like 2 chats earlier. But an agent, you can kind of give it the context of a short-term memory or a long-term memory. So in a short-term memory, it will be like what and all you have in the same chat thread. Like recent conversation, that history is maintained as short-term memory. Long-term memory is something like the agent kind of starts tracking some kind of important observations. And then using that, whenever it tries to answer in the future, this knowledge, it tries to uh, let it kind of affect its answer or use this as a way to give you better responses. And the last, on the other side, you have tools wherein it could be calendar, calculator, code interpreter is where you can execute your code, or you can have other APIs which you can connect it to. Anything and everything we generally do in our regular web development or regular software world, we can convert that into a tool and let the agent kind of access that. And all of this kind of comes out to the last one, which is action. You can think a lot, but if you never do something, right, it never amounts to anything. So as an agent, it after all this planning, after all this tool work and all, it comes up with a final action, which is eventually to try to answer the question that we had. Yeah. So different libraries have their own way of doing it. So crewAI, you can have like a function wrap it via some kind of crewAI's decorator or a class, and crewAI will be able to get that information and call it. So you just need to give some info like this is actually a function which will take this argument. So the LLM will supply that function argument, and the code will be just eventually calling it and getting the response. So the interfaces differ, but the essential idea is like it needs to call that function somehow. So the LLM will give that argument, and the framework which we ideally use will have the way of calling it. Generally, it could be like a normal function call. Right. So small breakdown of the anatomy of the agent, right? In terms of planning, it is pretty simple. Wherein first it does like a plan formulation, like what all I need to do. And once it's breaking down the big problem into smaller chunks, it does some reflection. Is this actually the right plan? Like maybe this step I can access this another tool to give it much more better answer. Or the response that I've given is not good enough. Maybe I can add more info. That kind of a dual approach it takes, where it first breaks down the problem and then tries to do some kind of reflection within himself to kind of give you the right answer. So the next one we'll see is a React method. So this reason plus act was like a research paper which was published, giving like a way for the LLM to start kind of giving some kind of proper responses. And the first one is the question. Like the question is like, aside from Apple Remote, what other device can the program Apple Remote was originally designed to interact with? So what and all can I use that Apple Remote to kind of control? So this is the question. So in your standard LLM, it will just directly say iPod because maybe it was only trained to know iPod is one of that. But in the reason only, where it's like a chain of thought reasoning, you only have the reasoning part. Like you give the LLM the way to kind of think, like how to do it like step by step. Like what and all tools does Apple have? Maybe what and all is actually supported by Apple Remote. So that also gives you only like a partial answer. The next one is 1C, which is act only, wherein the LLM only has a tool. So it tries to search for an Apple remote and it gets that information. Then it tries to access another thing. It faces an error. So the only thing it can do it is like keep on querying that tool, but it will not amount to anything. So in this React pattern, what we do is both this reasoning and this tool use, we kind of combine. You will both try to come up with what plan you want to and also the necessary tool. So the tool, if it fails, the planning portion kicks in and it says like, this is the error. So maybe we can add some similar question. Like if it see here, it asks for front row it is not able to find out. So it adds some more context, like maybe front row software. And when it asks for front row software, we get that information. And finally, we have that answer. And this one is also another way of LLM doing things, reflection, wherein in a regular project, right, you have like a maybe another pair programming or a QA where if you write something, they'll keep on questioning why you're doing this. This could be better. The variable name, let's say you're just naming it as I, they'll say I does not make any sense. Like it's not useful. Maybe better name it. So that's exactly what reflection design pattern is also all about. When a function is written, it will another LLM agent, or you can also have the same LLM do that kind of reflection, a thought exercise, wherein it says like, you have an error in this scenario. And as it keeps on doing, the reflection part kicks in, tries to better make your response. Like, yeah. And tool use, I think we saw some examples. Tool use, as simple as it is, like you let the LLM do the things which you would let it kind of connect to the external world or like some other environment to get any information the LLM as it is does not have access to. So web search tool you can do, like you have your DuckDuckGo API, Google Search API. Google Search, it can ideally do and give you latest information. And code execution tool also you can have, like Python, JavaScript, anything you have, you can do. Leverage this tool used to kind of execute the code and get the output. And memory also is something we discussed. Short-term memory is the information you have in the recent conversation. Long-term memory is like every time the LLM has a conversation, the important pieces of the conversation it kind of maintains somewhere so that it will have that entire sort of context. It's not active, it might not be actively used, but similar to humans, when we want to kind of reflect back on what happened very long time, it also tries to leverage this information. So how agents actually overcome RAG's limitations. Like it gives you autonomy. A RAG system, given a complex question, will not be able to know what to do next, but the agent can operate independently and start making the decisions to kind of better answer the question. Tool use, you give it much more access to the external world. It will itself be able to get the information. Task specialization is when you build an agent, you can bring in the best pieces of the prompt engineering, like give it a persona. Hey, you are a data engineer, you are a web developer. That kind of a specialization you can give it, and the right amount of context you can give it to better answer it. But the next piece is you have a limitation here. a single agent will not be able to answer everything. So in an organization, there may be mobile app developers, there may be front end engineers. So one person might not be able to do everything. Some can try, some can succeed, but at the best scenario, it's better if people try to have some specializations, which they are great at doing. So the next part of an important part we are gonna move on to is the multi-agents piece. So in the multi-agents, uh, it's kind of like you take all the pieces of the agent and you kind of just try to replicate it more. Similar, like in your DC comics, you have Batman, who has his own kind of special tools in his utility belt, his own way of thinking, his own way of planning, and everything. But for all the missions, Batman was not the right person to solve it. He might need help, and that's where we come up with Justice League or Avengers, if you're like a Marvel fan, wherein you bring in like multiple individuals with different kind of specialized skills and talents, and you let them kind of work it out who will do what to essentially properly solve the task at hand. So you have one LLM, one agent, you break it into multi group of AI. In a regular agent, you only have simple tasks. In a multi-agent, you break it, you can take up complicated tasks. One user persona becomes multiple user persona, and one more thing, in an agent part, you can have the human in the end. Like once the answer is given, you can go ahead and say some feedback. Hey, this is not what I expected. Try it again. But in a multi-agent, when the agents are actually interacting with each other, you can also in the uh, entire process itself, like somewhere, you can also give in your thoughts. Which like we'll actually see that crewAI lets you give feedback when the agent LLM agents are running and get better responses. So yeah, this is also the same thing. Like when you say the agent, we saw the design patterns. Like it has like tools access. It can make its own decisions. It has given a specific role. And if you saw the recent example of like there was this tool called Devin, which was saying that it is like an AI software engineer. So essentially using multi-agents, we can also build our own Devin, wherein like you have different agents, like a software architect, like a product owner, backend designer, backend developer, and QA, wherein each pieces of the, like if you ask an ChatGPT like system, give me the code, sometimes it gives you. But by means of using this agent, right, it will try to iteratively come up with that entire code base even if needed, by means of like having distinguished roles. Like I will come up with the architecture in which the code base should look like. The next person will say like we'll first take implement this feature, then the next set of the code we can take in, and the developer will come up with the code, and the tester will find out if there are any issues with running this, do all those kind of operations, and finally we'll have the way of doing it. So yeah, this kind of splits the session into the next part. Till now we just saw like uh, all about agents, prompt engineering, RAG, mostly theoretical way of doing things. crewAI is where you actually get to implement all the concepts that we kind of talked about. So crewAI is actually an open source framework which was developed to as a way of letting everyone kind of build their own AI agents. So it is actually built on LangChain, which is like a very famous library for LLM operations. And it has like a lot of strong community support. Like even recently, like if you check their repository, right, they'll keep on having lot of contributions happening regularly. And crewAI is also a type of library which gets frequent updates. So that might be a good thing also as well as the bad things, because you can't completely rely on their version. Like for one example, like we in one of our project, we tried to use crewAI. So when we had to move to like a future version, we had some issue with LangChain. Since it was built on top of LangChain, the LangChain dependencies was not properly set. So dependency issues, all these things is also a problem in this space. And crewAI lets you kind of use any type of LLM. You can be Olama, which lets you run your own local large language models, OpenAI, Gemini, Claude, anything you have. By means of LangChain, it has that way of orchestrating. Like you have like that interface, so you can use any LLM which you want to. So if we go to the GitHub repo of crewAI. So it's just a Python library, right? You can do pip install and kind of start setting it up. I'll show a demo of this in the later part of this. So you can also find this like repository GitHub crewAI and get more information here. And they also have like a good documentation wherein agents, how you kind of connect to tools, and some use cases also, like how you would want to kind of, they itself have some examples for crewAI. So you can just take one of the example, try it out, make some modifications for use case. That also is possible. So the next part, right? crewAI has some of its own concepts. Like the first thing is agent, which we've been talking all about. The next thing is tasks. So in tasks, right, the agent, you don't let it do what it wants to. You tell it like this is the action you would actually be owning up. Like as a developer, you'll tell, hey, your job is to write code. As a tester, your job is to write the test to validate that code. So that part we kind of leverage tasks to do it. And in tools, we talked about like, this is the way the Python code will get executed or accessing the API endpoints. And crew is where you kind of combine all of this. Like what agent will take what task and what tools all it has. Like you try to combine it into this multi-agent workflow, and that is what we call as a crew. And process is like what is the strategy the LLM is supposed to take in order to kind of solve your answer. So this part also we'll be actually looking at in another slide. So in terms of agent, right? Like these are the building blocks of crewAI. Like this is the very first thing you would need to implement if you want to build a use case. And it will take some information. When I say role, it can be like a software developer, an AI researcher, or a teacher, or depending on your use case, right? It can actually vary. Like if you are like a content creator, your role could be like a content creator. And your goal, you can say, my job is to actually come up with like an content for like an Instagram story that I'm supposed to post. And the backstory could be like I've been having this much amount of followers. I've been posting content about like tech for this many number of years, or any other information that can help the LLM give better answers. And the LLM part, you will give like which LLM you would like to use, what tools the LLM is supposed to use, and function calling LLM is like you can have one LLM kind of do the thinking and another LLM to just call for function calls. This is like not all LLM models are like cheap. Some are costly. So to mitigate that, like for function calling or tool calling, you can use like a cheaper model, and reasoning you can use like a better model. Step callback is like after every agent thinking is done, you can use this to kind of log it to some database, or if you want like that intermediate operations, you can have this. And allow delegation is like if the agent is not able to do something, will it have the option to uh, ask another agent to do that kind of task. The next part task is you give the description. Like in the content creator one, it will be like, hey, I want you to create like a story Instagram content within like some 50 words, and which agent content creator agent is what I wanted to do. Expected output, like I just want like an image, or I want like it to be in like a text format, a JSON, this information, what tools it needs. And human input is like, if when this task is happening, if the LLM would like to know my feedback, if we set this human input to true, that it will actually take that feedback when it runs. And tools also, we don't actually need to implement all the tools. So they have their own set of built-in tools, like for Google search, doing some kind of maybe a document search, all those things. crewAI itself has a toolkit wherein they have like a set of existing tools that they have implemented. We can also, since it's built on LangChain, use LangChain's tools which are implemented. Or if you have some custom use case, build your own custom tools. And I'll show you the existing available tools. Like you have a code interpreter where you can run your code, DALI for image generation, CSV search you can do. So all of this, you just need to import this from crewAI library. And if you give it, the LLM will be able to do these kind of operations as it is. So the last part is the process, wherein like sequential processes, as it is mentioned, right? Uh, if one agent completes, it calls next agent. After that, another agent is called. Hierarchical process is like you have like a manager, similar to how in a company there will be a manager. The manager will take the responsibility of which agent should I call so that I can actually do this task. Like there is no code, it calls the developer to write the code. Then I find out, hey, there is no test, I call the tester. Or if I need see that this if this aligns with the product vision, I call like the product manager to have some conversation for them to find out if it's needed. And the last one, consensual process, is something that is not yet implemented. It is like instead of like a manager or a sequence of doing it, it's like a democratic way of doing it. Like they themselves kind of plan it among themselves and come up. This one, I think it's not yet implemented yet. And you can see the same example here. Like this is an example for posting a blog article uh, on a blogging platform, right? So you give a topic, there'll be a first researcher agent. It will search on the internet and then get some information. Then you will go to the next part, which is like a writer agent. A writer agent will write that to like a database or a local storage. Finally, publisher agent. Let's say you want to write to Medium or Dev2 platform. You can just in the writer agent or publisher agent, give the tool for it to publish that blog. So by this means, right, you can kind of automate writing a blog post. Like every week, if you kind of schedule it, every week from your ID, like one new blog post can be published, which is a good thing as well as not a great thing. And in the same way, like if you can do it in a hierarchical way, all three agents will be there, but instead of going one by one, there'll be this manager agent, which will kind of coordinate which one should I run first. Once I'll have the researcher give some content, I'll write it. The manager is not satisfied. It will once again ask the researcher come up with more better information, and it will try to do that. So the final thing is crew, wherein like all the tasks you have created till now, all the agents you have created till now, and if you want a sequential process, all these things you do and create like a crew object, which you can immediately run it. So this is like a mind map of crewAI. Like what and all we saw till now is you have AI agents. Each AI agent you can kind of assign it like a task, and for solving this task, the AI agent itself will have some tools assigned to it. It can use that tool, and all these AI agents will follow this process to kind of solve your answer. And all of this combined, we call it as a crew. So human in the loop is something we talked about. Like you, before let's say publishing, I don't want it to keep on publishing any content it comes up with. It will ask me like a feedback. So this is like semi-autonomy. Instead of the LLM agent simply running and completing, it asks a human for like, should I proceed with the operation or should I stop it? Do I need to give better content? That human in the loop, this will do. I'll show a use case. So yeah. So what all I've done is like first the demo, right? I'm showing it in using Gemini API. So that is actually like Gemini gives you free API for trying out large language model prompts. So I'm actually using that. So you just need to install the LangChain library for Google Gemini. And then for implementing crewAI, you would actually need to install crewAI. And since I'm actually trying some tools, external tools provided by crewAI, like I'm also installing the crewAI tools library. And for trying some internet search, I am also installing DuckDuckGo search, which will do the search in the internet. So Tavily is also similar to DuckDuckGo search. It's like another search kind of API, which will, given a question, try to search the internet and give you some responses. So, so what I've done is like all this API key I've actually loaded. And one thing I learned to recently is like Google Colab has this secrets feature wherein you can actually add any API keys and all you have it directly here and give it the value. And from any notebook which you would want to access this one, you just need to toggle it and you'll be able to start accessing it as like an environment variable and running it. So we import the crew agent task crew from the crewAI and okay, we'll execute and show. Okay. So this is the agent implementation, right? Like LLM model I'm creating, like Google Gemini AI, which model I want, Gemini 1.5 Flash, and the Google API key I'm giving. And so the use case we are actually doing is the same one, blog post. We'll have a researcher, we'll have a writer, and we'll have an editor instead of a publisher. The editor will say, this is good, this is not good, maybe make some changes. So the agent researcher will have the role of a content researcher, and it will tell you information like, hey, plan engaging, factually accurate content on this particular topic. You've been working on this topic for on planning a blog article. You are kind of doing this. You need to collect information, write something that the audience would kind of prefer. The next part is you implement a writer. In the writer, you say, hey, the content researcher will actually give you some information. Use that to write it in the form of a blog. Like you'll have an introduction, you'll have subheadings, and finally some conclusion telling the user this is what the blog article is all about. And you give like role, goal, and then backstory, and which LLM model you would actually want it to use. So in agents also, we can actually differentiate. Like each agent can have its own LLM model also. That is also possible in crewAI. Allow delegation, I'm setting it false. Like I want to run it like a sequential one. Researcher, writer, and editor. And the last one, editor, is like the content that the writer gives. It will just see like if it's grammatically accurate, if it's having so many bias, some this kind of information it tries to implement. Okay, I think it's still running. I'll show here. So the next part is like we create tasks. So in tasks, right, like we give it like this is the task for the researcher, and your work is to identify the latest trends from the internet, find the right target audience, and what SEO keywords you want to use, and expected output, right? Here I'm just asking text. Here you can say I want it as a JSON. This kind of prompt information you can give it. So the task is the part where you will kind of say what you actually want to do, and I will assign it for the researcher agent. And write task, I give a description, the expected output I want, which is like a well-written blog post, and I assign it to the writer agent. And finally, the editing task is like proofreading the given proper blog post for grammatical errors. So the last part, crew, is where like in the agents section, right? I say researcher, writer, editor, and in tasks I say you need to research, write, and edit. Like all of this we created earlier. The objects of this one, task and agent, we just add it as a list. And the process here is sequential. Like default is sequential, so I'm not specifying that. So crew I'm executing here. So on the topic I'm asking it is like, what is the most recent trend, AI trends in September 2024? So if you see the output that is given, the first agent is content researcher. And the content researcher will have the task like, I need to prioritize the latest trends, who are the key players, what and all content I can actually give. So it is using the existing knowledge of the large language model without any external tools at the moment. So it is seeing like, hey, AI is used for healthcare, AI is used for edge AI and IoT integration, OpenAI, NVIDIA, these are the key players. And all this information, the large language model is trained on, it is able to get this information. Once this information is fetched, it will call the, it will complete that first part and give the output to the next one. The second agent kicks in. So when the second agent kind of kicks in, it's a code writer, content writer. So it has taken the inputs that the first one is giving, like the information like key players are Google, NVIDIA, what are the recent trends, and it tries to come up with this blog format in a markdown fashion. Like this is the heading, the future is now, unveiling the hottest AI trends in 2024, and some subheadings like generative AI, then conclusion, all this information we are writing. And once this is created, third one is your content editor, which tries to kind of think like, hey, I want to align it with the style of the organization. Here, I've not given that information. So if your organization has like its own way of doing things, that kind of additional inputs also we can give. So the content will be generated in that sort of way. And finally, this just tries to do some refactoring and all that and gives you this output. And we right now have like a very short blog. So this is like what we get as a result from the crewAI without any tools as such. So similarly, right, another question I tried is like, uh, the result of the test match between like India and Bangladesh started like last week, 19th September. So when I asked this question, it kind of, so I have actually trained this earlier. So it with the use of memory, the very first time I asked this question, it was talking about Mahendra Singh Dhoni, like played a very great innings and was telling me that. But as I kept on asking the same, like for the demo, right, I was running this again and again. So the memory, it was updated. So it figured out, okay, like India actually won the match, but additional information it is not able to give, like who won, all those information it is not missing. Like because in the content it did not actually have it. Like it does not know how much the score was. All that information was missing. So the next part we go is tool usage. So what we are going to do is like we are going to use a Serper dev tool, which is like a Google search API. Serper is kind of free for some limited set of search. We can also use the API, and given a question, it will try to get like search engine results and give it to us. So what I'm doing is the existing researcher, I'm making one small modification wherein I'm adding a tool. Like in the tool, I'm saying, hey, you can actually run search tool. And the search tool implementation, it's actually defaultly from crewAI. So I'm taking it as is. And in the task also, I'm just changing it, like researchable tool is what you're going to use. And some information. I think like you have access to a search tool using which you'll be able to get real-time information. Use this tool to get the info, but try not to hallucinate. So I'm creating another crew with the researchable tool and all this information. And when I execute this one, for the most recent AI trends, the researcher is actually having access to a tool. So what it does is it tells that, hey, I need to search the internet to get more info on this. So it goes to the search query and gives like, I want to find out AI trends September 2024. And here you can see like the recent trends of, let's say Coursera, in the website, they have written something like Gen AI democratization, AI for workplace productivity. All this information, it gets it. What are the rapid trends? All this information, it gets it. And then once it feels that information is sufficient enough, it tries to compile that and give it. So once it compiles, we get the final output. So based on whatever search engine results we actually got, we have some info here. And one more thing, same question I asked for India versus Bangladesh match. And here, if you see, the blog post was not good enough, but at least it was able to give me the content like the match happened at Chennai at September 19th. India won by like 280 runs. And all this kind of information, at least it was able to get that. But here also, I would say it's not still proper. If you see, I thought 404 is actually the right score, but when I checked the internet, it is not 404. So here also, even using tools, since I've used like very minimal prompts, it has not been able to properly get it. So the agent also, I'll say it is not your silver bullet. Like you still need to do some more ways of work, better ways of doing implementation to get better outputs. Mhm. So the content, whichever it is taking, right? I think it has not been able to get that proper info. Like the score which is getting, I think it's not properly evident in the final one. Like whatever it is passing, that agent has that access, but whatever is passing to the next agent, it is not properly giving it, so it is not able to do it. In ideal scenario, like we can update the prompt, ask it to do it much better job. Like only rely on the agent tool. Like you don't come up with an answer, or this one is a sequential, or it can let it hierarchical. Like the manager will tell, this is not based on the content he generated. Run it again. So that kind of operations we'll need to do, and which is where the agent complexity kicks in. Like we can't always like orchestrate it like a regular system. Sometimes it gives the output because like this time it was hallucinating. Once when I tried, it actually gave the right output. So I tried to run it again and again to get the same output, but it was not able to. So that kind of challenges comes with the agent part. So one more quick example is like, if you want to build your own tool, like this is like a Tevili client. What I do is I wrap this tool, uh, Python function using this tool, and then I have this response. So in a real world scenario, this could be anything. Like you have your own enterprise API, or you have your own other ways of doing things, or another API. You can just implement that and put a wrapper on top of it using a decorator. And you give the same approach. You give the tool access, you sort of run it, and the crew execution, right? If you see it. So this one has its own way of getting the answer. Like if you see, it gets information like top AI trends to look in 2024. All the other information it tries to fetch, and the final blog post it tries to kind of use this one to get it. Yeah. And for human in the loop, right? Human in the loop, only thing we do is like you add this option called human input is true, and then when you kind of run it, it will kind of ask you like what is the feedback. I think I took a screenshot. So once the content was given, right, it asked me like, please provide a feedback. I said like change this heading into a different thing, and it ran once again to kind of give me that kind of an output. So here, same thing I'm doing. Only thing is human input, I'm setting it as true. So some more use cases, right, which you can kind of do is like one thing we tried out recently was like a data interpreter. Like you have access to your Python code. So given like the data retriever can be something that can query your SQL database itself, generate the SQL query and get the info. Data summarizer can say, based on this information, this is what I'm actually thinking is happening there, and a visualization. So if you want like a dashboard or a charts, you can do that. Marketing campaign is something you can do, wherein like you have a researcher, the same as the blog post. Instead of writing a blog article, in the end it will be like a, hey, we can send this kind of a marketing campaign ad. Trip planner, like you can let the agent select the city it wants to find out, and using the search APIs and all, you can make it query, treat it as a local expert agent, get that information, what are all hotels we can book in that place, what are the best sightseeing places in that, and finally use the travel concierge to give that kind of output. And finally, the example we talked about, like a software developer, you have a coder, tester, and finally a reviewer to say, hey, this is actually right. So other multi-agent tools in the market, right? Like you have Autogen. So Autogen, in terms of code implementation, is very similar to crewAI. Same, like you can give like the backstory, all this information, but in a different name. But the only challenge is like crewAI, I would say it's little simpler. You can kind of give it like this is the task you do, and it follows that sequence. But sometimes Autogen, what it does is it takes its own way. Even crewAI does that. Like what it does is like in the India versus Bangladesh match, same question, right? Sometimes when the tool was not properly giving the output, it went on this sort of like a loop. It was keep on querying that endpoint, and it exhausted the resource for that. So that is like a big no when you go to using some other tool. Like if you're using like a paid service API, you would not want the LLM to call that endpoint to a point where it will kind of cost you so much. So that kind of challenges are still happening, and I think the libraries are still trying to come up with ways to do that. Because if the agent was the best way to do things, I think everyone would have started implementing. So right now it's, I would say in a POC state. Production, I think it's still trying to progress there, but not everyone is like hopeful about taking this to production. So maybe if you're an internal workflows, right, something that can help you, this can be really great. But I think it still needs some more time to mature for us to start taking this to production. Meta GPT is also a similar open source thing, which is similar to Autogen. But the Lang graph is something which I've been hearing like really great feedback, wherein instead of taking it does everything crewAI and Autogen does, but in top of that, it tries to approach it like a graph actually. Like different agents come as a node, and based on that condition, like whether it's satisfied, it orchestrates multiple paths. Like in a graph, you have your nodes and edges. So your nodes will be your agent, and the edge is defined by what output the particular agent is responding. So LangGraph is also still evolving. This is also developed by LangChain. I would say LangGraph is something, if you're interested, something that you can look into, because I think it's gaining much more adoption recently. Benefits, I think we talked about. Best practices, to keep it simple, uh, you have a problem, break it down into an agent design. What and all will be the roles to kind of do it, take it up. And immediately do not take like 5 to 10 agents to a final use case. Start with something small, see if it's actually giving it right, try to make some more optimizations, and then scale it up eventually. And give it the right agent autonomy and control. Like sometimes don't let the agent entirely run it, but don't take the complete control, then you lose the value of what an agent is. So find the balance where, as a human in the middle or something, like this is the pieces where agent can actually do make its own choice, and this is where it might need human feedback. And with this, we talked about tool calling and all. We can use some lower, faster models. And since it's executing the code, right, Python code, like that also we need to have some additional checks to see it's not running some malicious code. So that kind of an security also we need to do. So AutoGen, what it tries to do is it has like an option wherein if you want to run the code, you can run it within Docker instead of your regular work environment. So that is like one approach where uh, code execution can be made secure. You can leverage local models. And yeah, this we talked about, like the latest changes in the repo. Right, we need to keep on updating if we're implementing. And final thing is like maintain logs and metrics. So in our implementation that we did for client, the us using a multi-agent, the outcome was that like sometimes we just needed a way to tell them why it failed. Like they were not worried about why it failing, but more about why did it. Like we had like a proper logging system in place so that we were able to show them like this is what the agent thought at this point, and this is why it was not able to come up with this one. And then by using that, we were able to justify, and the prompts we were able to update. So if you don't have any prompts, sorry, any logs, you won't know why it failed, and you can't update or optimize the system as needed. And yeah, final thing is challenges. Response time, sometimes when you run it, it takes a long time. Like they try to go on inside its own loop. Coordination complexity, uh, as the agents size, the number of agents starts to increase, which one we should call at which time. In the sequential, it's simple, but in a hierarchical, it gets much more complex. Inconsistent results, as we saw in the demo, sometimes the result of which we get is not what we would ideally intend to get. And frequent update and dependency issues is something I talked about. The crewAI dependent on LangChain, so they're trying to overcome it, but I would say it's still a prevailing problem. Security and privacy, since it gets access to executor code, call some APIs, this is some part where you will need some more control to see it's not uh, exposing your information, like if your enterprise information or anything. So yeah, I think that covers it. You did, you said about the starting of the codes has been implemented by themselves. Like example, you say the average of the age, and it was analyzed and was mentioned that the math, default in math, starting from something, and evaluated, and then how is the possible using. And the second thing is that said about the uh, drag and compare with the another, somewhere comparison say that one of the field of not was of more isolated, and the next for the RAG is less than. So it's not able to proceed in the upcoming years with fully to your particular sector. And the third question, it's not able to connect with other products like one for the MongoDB last time we used that for they said of the Mongo and to attach with the DevOps Docker using, and it was being implemented was in that is the people. So for the first question, right, importing, how it does is like in a large language model, in ChatGPT, when we give a code and we say, hey, this is the error, ChatGPT will tell, okay, this by means of this error, I can tell it import math is missing. So here also the same only we are doing. So the tool is getting executed, and the exception output that is getting, we send to LLM. The LLM is telling input math is actually missing and it gives the corresponding code also. So in a regular scenario, we will be the ones asking the question. In an agent, it automatically does that kind of chain part so that we don't need to do that. And second question was in for terms of RAG, right? Hallucination, I would say hallucination is a bigger thing. Like another thing that is actually growing towards and trend is agentic RAG. Like you take the RAG, you come up with an agentic system wherein like the RAG will decide, like a router sort of like what data source should I do it, or some other ways for a fact checking agent that will kind of come up and see if it's actually right or not. So I would say the problem is not completely solved. Hallucination is still happening. I would say like with the large language model, I would say hallucination might always be a problem. The closest thing we can do is like we can use this additional you saw reflection, these kind of additional steps to find out, do some kind of way to tell that hey, it's actually correct. And another thing is explainability. Like if the output you are giving, you can say this is the document I'm getting it from, or this was a tool response. If you can properly explain the answer, I think hallucination, at least you can't solve it, but at least you can tell if it's actually doing it the hallucination or not. Third one, MongoDB RAG system. I'm not aware of that. But what I would say is like if it's available as an endpoint, the same way we saw like a custom tool where we wrapped it, if it's giving like an endpoint or some way of consuming it, we can leverage Python itself. We can implement that way of interacting with it, and we can give it to access. So if the LLM is not completely aware of that, it might not be able to. So if it knows about the MongoDB enterprise, if it has that context, it will be able to proceed. If not, LLM also will face some challenges. It will not able to properly solve it. This time it will try to go in a loop trying to solve it. This kind of checks only we need to keep. Like one way crewAI lets you do is like you can set the maximum of iteration. The agent thinking might not go beyond 10, 15. That kind of checks we need to have in place and do it. So and that's another reason why these are not completely automated. This a lot kind of right now is heavily dependent on some user, human in the middle. So we right now have one where like given a natural language question, you can come up with like a SQL agent, a SQL query, summarization, and like visualization. So that part we are doing, and we are having some challenges, but right now like we are using that. Because for SQL, like what happens is like tool access what we have given us it to automatically query the schema. So if you can tell this is the database or domain like schema you want to access, all the tables, column information, we also give like metadata, like data comments and all those information, data types and all. So the tool will actually fetch that, and the agent SQL generation agent will try to use that schema information to come up with the SQL query. And we have another tool which will kind of go and execute the SQL query, could get the data. Some sample set of data we give to the LLM. It will try to summarize, hey, this is what I'm trying to find from this one. And finally, it goes to visualization. Visualization, we're not using an agent per se, it's just a prompt right now. So if it goes based on the data and like I want a bar chart or something, it will give the Python code which we execute to show the bar chart.
agent is like different agents. For example, now we are having a use case for research. So we have a manager and a reporter and a publisher. So three types of jobs we are writing, and each agent performs a particular task. Okay. So in a layman's perspective, like we just say like it just looks like a couple of functions and metrics that you filter out. For example, for a research, right? You just used a search, maybe a DuckDuckGo search. Basically, you're hitting an API with your query, and you're getting a response in a JSON. So after the JSON, right, you have a response, you have a content here. So basically, the reporter, right, if I mean the reporter agent, a summarizer agent, it basically summarizes. And the validator agents also is the same LLM. We are using a general purpose LLM in this case. So we are not using any specialized or trained LLMs or models for each specific use case or specifically trained for these tasks. So we are using a general purpose LLM use case, and we are writing a couple of functions and connectors to it, and validating it. Okay. So it works fine because you keep on nudging it to do. Because these are large models and you are using OpenAI, Gemini, it's very large. For example, there are open models like Llama 2 and 2 billion parameters are small models. Even if you nudge them, even if you put agent, they won't work. In my agentic life, it won't work. Because we all know, is it a stretch calling this agent will solve the problem? In my eyes, it looks like there's a function call and there's a validated metrics we have. And maybe some good practices where initially we don't follow any problem. Basically, this RAGs is they extend their way to say it's not. It's like a coding practice or something like that. What do you know?
Yeah. So LangChain actually has this feature called prompt change actually. So similar to what you do here, like you can say, first ask this question, next question take this one, next question take that one. So in a regular world, that's like a static system. So agent where it comes in is like, if I don't know the next step, the agent is supposed to come up with that next step to tell what to do. So if you know the flow, this is what you want to do, I would suggest it's actually ideal to stick with prompt engineering, because agent might be overkill for that kind of use case. Agent you would generally need when you don't know the kind of possible issues that might come up with, or you want the agent to kind of keep questioning itself to come up with the final answer. So that is the first part. And the second part is in small language models, right? I would say agent at the core, right, is having this agent as LLM as the brain, sort of. So if you see this slide, the entire agent is kind of revolving around the center part of the LLM. So LLM is the agent's brain. So as a like regular context, right? If the center part of that is not actually good enough, then you can't expect the results to be also good enough. That is another reason agents have not gained, like they are getting adoption, but not maybe yet in production, because they might still need some more ways of doing it. And this is something we also talked about, like in our when we're building the use case, we did not start with an agent. We started initially with the prompt engineering. We gave a schema. When we felt like, hey, like we might not be good enough, like how much time will we keep on sending the schema dynamically? Then we thought, okay, let us try with something called function calling. OpenAI has that function calling option. The function calling, given a parameter, it will tell you like you can use this query to kind of get the information. That we tried. That also was kind of coming up with some issues. So we thought, let us start having like a for loop, which will kind of send the error messages keep back and back. So essentially, that is an agent. So in a prompt, you just limit to having a sequential flow. In an agent, it's like a for loop. It keeps on going it. But if I have it in a for loop, when do I stop? When do I kind of find out this is the right answer? So the agent helps you with that. The way the agent is implemented, it will have like, this is the part where I need to stop with the answer, or this is the part I feel like I overshotted my implementation of solving this. Like I'm keep on asking, but I'm not getting the answer. So I need to stop it right away. So the agent has your way of doing it. So it's like an abstract way of doing the things. You can also like implementing an agent framework. We also can do it right away, but it's available in the market, so it's easier to try it out. And I think in future, it is possible, like it can gain widespread adoption, but the current state, it is challenging.
large language models is the brain of the thing. For example, if you use any small models, for example, a very inefficient model, so those cases, right, it won't work well. So basically, the strawberry problem. Recently, because using chain of thoughts, they say like in the new model, ChatGPT, OpenAI thing, I think overcome the strawberry, how many hours in strawberry. So the agent, whatever use your model, how many times you ask the same question, give the reason of thoughts. Your limitation is cut down with the LLM model.
So that's where you come up with tool use, right? You give it a Python code wherein like it will try to find out the number of R in like in Python you can find like R in. Yeah. So tool use helps that.
Right. This conversation can be taken offline in interest of time. Before we proceed for the next talk, we'll take a short 10-minute break. The snacks and tea are served in pantry. And before you go, we have a simple ask. I see a lot of familiar faces here.